In the name of God, hello then, dear students. My name is Masood. I'm a physics teacher. I'm at your service to explain physics curriculum grade 11. In previous lesson, I solved two questions from our practice 1C page 17. Right now, we are going to keep going our solution by reading the question number 3. A driver in a car traveling at a speed of 78 kilometers per hour. So this is the velocity of the car. Uh, it says after that the driver sees a cat. So this is the first information, velocity of the car. Then the driver sees a cat 101 meters away on the road. The driver sees a cat, right? Seeing is a process, right? Seeing. How long? How long? So what do we look for? We look for delta t. How long? How long will it take for the car to accelerate uniformly to a stop in an exactly 99 meters? So you know what stop is, means the object comes to rest at last, means final velocity v final is equal to 0, right? But here it says the object stops at exactly 99 meters. So what shall we do here? What's our duty? We have two displacement, 101 meters, 99 meters. I want you to neglect 101 meters as if there's no this number, right? Neglect it, ignore it, uh, because we concentrate we concentrate on the stopping case. We concentrate on let's say an action, right? We don't concentrate on seeing action. The driver just see the cat from afar, but it says the driver stops physically. Physically, the driver stops at exactly 99 meters. That's why 99 meters is a real displacement. 101 meters is not considered displacement because the driver just sees the cat from afar, right? How long will it take for the car to accelerate uniformly? So, and before I solve the problem, we have a conversion here, like the previous questions. Velocity is given in kilometers per hour, and the displacement is given in meters, right? Uh, I want you to convert the velocity into the meter per second, right? Because converting 99 meters to kilometers, it's a little bit, it's not very common. That's why here I want you to convert kilometers per hour to meter per second, right? Uh, V final is equal to 78 times 5/18. So here, put the denominator of 1 for 78 times, I want you to multiply 78 by 5. So you get the number. After that, you have to divide the result by 18. And the answer is 21.67 meter per second. And the V final is almost equal to 22 meter per second. Right. So this is the first step. The first step was conversion. Conversion matters in our solutions. I told you last lesson. After that, the second step and the last step, delta t is equal to delta x over v initial plus v final. Maybe you say, teacher, where does this rule come from? Let me jog your memory to the original rule. what's the original rule? Delta x is equal to 1 over 2 or 1 half v initial plus v final multiplied by delta t, right? This rule comes from the original rule. I want you to, let's say, take out delta t here. Delta t is unknown. That's why anything that multiplies by delta t goes to the denominator. So this bracket goes to the denominator, goes down, and 2 multiplied by delta x goes to the numerator like this. So delta t is equal to 2 delta x over v initial plus v final. So delta t is equal to times delta x is 99. It's not 101. I explained it for you. 99 meters divided by initial velocity 22, right? You are not allowed to write 78 kilometers per hour because you converted it before, and the object and the number would be 22 meters per second. 22 plus 0, and the answer is equal to 9 seconds. Right. Let's move on to another question, which is question number 4. And this is the last question for this practice. Let me read it for you. I'm going to read it for you. A car enters the freeway with a speed of 6.4 meters per second. Right. It seems that this velocity is the initial velocity because uh, according to the question, it says a car enters the freeway with a speed of 6.4 meters per second. It seems that this is initial velocity and accelerates uniformly. Accelerates means it speeds up. It speeds up uniformly for 3.2 kilometers in 3.5 minutes. Right, 3.2 kilometers actually is displaced during 3.5 minutes. How fast? So it says how fast is the car moving after this time. So we look for V final. We look for V final because initial velocity is given 6.4 meters per meter per second. Delta x is equal to 3.2 kilometers. Delta t 3.5 minutes, and Vf is unknown. If you take a look at these units, each quantity is given by a different unit. That's why we have more than one conversion. I want you to, let's say, unify the units into the unit that is verified in SI, that is valid in SI, right? Uh, like this, you have to convert minute to second, kilometers to meters. It's very easy. Kilometers to meters, conversion is taking place from larger to smaller. That's why the exponent will be positive 10 to the 3 or multiply by 1,000, right? And this one is right. So this value is 10 to the 3 or 1,000, right? 3.5 minutes. Each minute contains 60 seconds. That's why you have to multiply the number by 60 in order to get the time interval in seconds, right? Like this. Delta x will be 3.2 times 10 to the power 3, and the answer 3,200 meters. Delta t is 3.5 minutes. Whenever you times it by 60, the answer will be 210 seconds. So our new displacement and time interval are 3,200 meters and 210 seconds successively. Vf is equal to V final is equal to delta x over delta t minus Vi. Maybe you say, teacher, where does this rule come from? we haven't, let's say, had this rule before. We have a point, but let me remind you to the let me remind you of the previous rule, of the original rule, right? This is the rearranging of the original rule. The original rule is delta x is equal to 1 over 2 initial velocity plus final velocity times delta t. So the origin of this law is this one, delta x 1 over 2 or 1 half vi plus vf times delta t. We look for v final, right? Uh, I'm not gonna prove it for you. It takes time actually. Uh, that's why this is the rearranging of this law for VF, for V final. You have to, in order to, maybe you wanna know how to reach this form. I'm just explaining the law, explaining the steps quickly. I'm not gonna do it for you, but I'm gonna make it easy for you to get this form. Actually, firstly, I want you to multiply this coefficient by each term within the bracket, right? So this 1 half is not just for the first term, it's for the second term as well. After that, and one more thing. Furthermore, this delta t is common for the bracket as well. So you have to multiply 1 over 2 or 1 half by VI and VF separately and multiply delta t by VF and VI separately. After that, you rearrange the equation to get this form. Or you can memorize this rule like this. Memorize the law like V final is equal to delta x over delta t minus V initial. I want you to do it because you are grade 11, you are good at mathematics. I'm sure you can get this form. It takes only 2 steps. Right. V final is equal to 2 times delta x. We converted the delta x from kilometers to meters. So 3,200 is valid in this question. Divided by delta t. Delta t is 3.5 minutes, but we converted it to 210, right? Minus 6.4. Initial velocity does not need any conversion because it's given in a unit that is valid in SI. Right. Firstly, I want you to simplify the fraction. I want you to multiply 2 by 3,200 and after that divided by 200, divide by 210. After that, the result, you have to subtract 6.4 from the result like this. The result of the fraction will be 30.5 minus 6.4, and the answer is approximately 24 meters per second. This is the final velocity. Thank you very much, guys, for watching this video, and see you.